Hello everyone, I welcome you again to our YouTube channel. My name is Professor Kevin. So please, if you haven't subscribed, please just subscribe and don't forget to like the video and also share it with your fellow learners or your friends. Ne? So today I will still be preparing you guys for the trial examination. So today we'll be focusing on probability and the counting principle. Ne? All right, then the question for today, we are given this word calculate. Consider the word calculate. Okay, before we can go through the questions, let's start by analyzing this word calculate. How many letters do we have from this word? I think we have 10 letters. We're having 10 letters. Okay, we have 10 letters from this word calculate. Then how many are repeating? We can start by C and C. We have two C's. Okay. Then those who are repeating will also have A and A, so we have two A's. Also have L and L, so it will be two L's. Then the other letters are not repeating, so we'll leave them the way they are. Let's go through the question. The first question says, how many different word arrangements can be made from all the letters of the word calculate? Okay, so it is simple. We start with the number of letters that we're having from that word. How many letters are 10? 10 factorial. We're going to divide it with the number of letters that are repeating. The first one, it is C. How many C do we have? It is 2. So it will be 2 factorial. We're going to A. How many A's do we have? It is 2. So it will be 2 factorial. For L, we also have 2L. So it will be 2 factorial also. Then let's see how many ways do we have there to arrange this word. Then 10 factorial divided by, I think it's going to be 8. Okay. Then I think we're going to get, it is 4, 5, 3, 600. These are the number of ways that this word can be arranged. Okay. Then let's go to the next question. What is the probability of making a word arrangement that will start and end with the letter L? Okay, so it means now the letter L, it is at the beginning of the letter and also at the end. So okay, or let me write this. How many letters do we have? It is 10 letters. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, we have our, okay, if we place L, it will be 1 L, and then here it will be 1 L. Okay, here will not be having L. So okay, and those letters that will be here, they will be changing the position. Let me start. It is we'll be left with 8, 7, 6, 5, 4, 3, 2, then 1. All right. Okay, this is our condition. So we're going to say because if you can check, we have 8 letters that will be shifting or changing the positions. So we can simply focus on those 8 letters only and leave this one for L. So we're having 8 factorial divided by how many letters are repeating. We have 2 letters for C, so it will be 2 factorial. How many letters? We have 2 letters for A that are repeating. Then for L will leave it the way it is because L will be here and also here, so it will not be changing any position. Let's just exclude it from this one. Okay, and then let's solve this question. We're going to have okay, we can use our calculator to identify the number of ways. So it will be 8 factorial. Okay, 8 factorial divided by 2 multiplied by 2 is going to be 4. Then we'll be having, let's see the number of ways, 10,008. Okay, cool. So those ones are the number of ways, but the question was to identify or to calculate the probability. So we are not done answering the question. Then here, this is how we're gonna finish this question. We're going to take this 10,080. Oh, 10,008. We're going to divide it with the with this one of 4, 5, 3, 600, and then let's see what are we gonna be having. It is 453,600. Okay, 1 over 45. 1 out of 45. So that's the probability, né? Yeah, of arranging this word if we're gonna start with the letter L and also end with the letter L, né? Then we are done answering that one. Let's go to the last question. Then the last question says, in how many ways can all letters be arranged if no similar letters should be close to each other? Okay, it means there will be no similar letters that will be close to each other. Okay, to answer this question, we can simply start with the number of ways when we've placed the similar letters close to each other. Let's start by that number of ways if we have written all our similar letters close to each other. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then let me do this. Okay, don't forget. Okay, so we'll be writing all those similar letters close to each other and identify the number of ways. So don't forget the letters that are similar. We have this one C and C. So if we have C here, C, and then we place C. Also A, and then we can write A here. We can write L and then L, and then we'll be remaining with the 4 letters. So I can write 4, 3, 2, and then 1. Okay, so this is how we're going to solve this one. We're going to have, we have 2 multiplied by 2 multiplied by 2 multiplied by. Okay, so I want you to notice something. This one will be close to each other. Okay, so we're going to have how many ways? This one we're going to count it once, 2, and then 3. Let me erase this one here so that you can see. Going to count it once. It is combined because it will be close to each other. Then 3, then 4, and then 5. Yeah, 6, and then 7, isn't it? 1, 2, yeah. So it will be multiply what? 7 factorial. Yes, multiply by 7 factorial. Let's check what is our answer here. Okay, going to write it is 8 multiplied by 7 factorial. Okay, we're going to have 40,320. Okay, 40320. Okay, 40,320. Okay, then yeah, these are the number of ways when all the similar letters are close to each other. But the question wants us to determine the number of ways if the similar letters are not close to each other, because they said if no similar letters should be close to each other. Okay, so this is how we're going to find the final answer. All right, this is how we're going to find it. We're going to take this one of 453,600. Then we're going to subtract this 40,320 because we want to be left with the number of ways when the similar letters are not close to each other. Okay, so all right, it's going to be 453,600 minus 4320. I think we're going to get 413,280. So these are the number of ways when there's no similar letters that should be close to each other. Then we are done with that one.